So hi, so like 2 days ago, 3 days ago, I did some kind of live coding that seems like practicing for the interview. And I I implemented Btree, the insertion part and the search part. But right now, I'm just gonna like practice um some kind of interview that refactor my original code. So let's begin. Um, the thing, the thing um, I didn't really take care while implementing the B tree um, was the clean code. So I'm just gonna enhance this kind of the minimal but the core thing. Um, my example the barber name and the function name and properties name and whatever stuff. And second I will do um, um, split this class based logic into functions. The reason why the reason why I'm gonna change class based logic into function is because hold on is into function because um, the class-based logic was kind of hard because the page insertion and the search is a bunch of recursion. But so so implementing using function could be more nice. And third thing, next thing I'm I'm gonna do is split into file based example utils and the core folder or whatever entry index file to make it visual as a possible. So now, if you look at this kind of page class, and there's a bunch of properties, and I know this properties uh, is 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 able to readable, but however, these property names are um, name doesn't represent this page class. And also, I don't really prefer the class based OOP, and because even modern JavaScript library they uses the function rather than um, the class based. So and first, this is the class, and I think making the page class would be much nice, but 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 without rely on the property, um, it's kind of better to think about this way. Think about the property. I think is better to declare as the constant object. So right now I'm just gonna implement the functions that the output the properties value. So if I call these functions, it will create this some kind of object that has the keys and children and properties, whatever properties in here. Export const um, page um, um, the I think the most appropriate bar name is gonna be start with a page or page yeah, Btree page node, yeah, page node implement by function. Since this is function um, expression, I would return properties keys. The since the key, I think the rather than naming as a keys is not quite readable, quite able to understand. So I rename as a record keys because the page has record keys rather than just keys. But that's kind of really just the preference of the people. Next is children. The children and record keys default value is array. And the I'm just gonna declare as a no for the default. How do I run print here? I think there makes sense. Pre tier. So the properties we're gonna have this records and children, max keys length and min keys length, and even degree. And I will just name it just like this because this is kind of really inner property that it has to encapsulate from the it has to encapsulate and it has to be private. But however, since JavaScript doesn't provide a private object or the class, so we're just gonna just naming that don't touch it. Return properties. So right now, if I run this Btree page node implemented function, it will create the properties. So yes, like this. So rather than rely on this kind of class, we just create the properties. I think, I'm sorry about keep saying I think. Next steps is receiving from the constructor. Since there's no constructor, I would do receiving from the parameters here. So the page so the properties, I think so node is gonna be type of the properties. So node would since there's no type, we're just gonna put it here. If there's node that keys record keys, we will revise the original record keys as the node record keys. And rather than doing it, I think, yeah, this will be nice. Node that record keys. If there's no of it, just return empty array, and let's do it like same thing. D4 is gonna be null. Yes, we implement this node page implement function, but it just seems like having a constructor. Yes, but this node could be have this node could be undefined. So yes, now this is working. However, this code is kind of really a mess because we just having a fallback, but this fallback is actually our default value. Rather than doing is, I would do if there's no node here, if there's value here, get the properties and assign it like this. Node that record keys. Because we are pretty sure there's something node that record keys, and yes, like this. Yeah, if there's no pretty, so it's gonna be, it's really mess. So I'm just gonna install pretty here. I don't know. I think I have to install the prettier, but I'm just really lazy, so I'm just gonna keep it as stuff. Properties. Yeah, I think like this code is much better, but this is actually the same. But I'm just gonna keep it because there's a lot of things to do. I could make this kind of property, this kind of code much much simpler and much better, but there's a lot of things to do, so I'm just gonna put the to do here. To do have to put the node assignment outside of this obj. Yes. And then next is the get max keys length. Since this function is really kind of definite and is never gonna change because this is kind of formula, I would wrap the static functions into into here, but I would put sorry, utils or whatever file. But let me just try to copy this first. Export functions. Yes, like this. Export function. So this get max keys and this get min key length is actually the formula, and put it into utils file will be much better to read. So putting utils file or this page Btree utils are gonna be much better. Or formula is gonna be formula. I think, yeah, better naming as a utils file, but however, if there is utils that about array number etc, have to migrate this file into Btree or whatever Btree utils.ts. Yes, but we're just trying to make it as a temporary thing. What is TS? And next step I'm just gonna do is since I already create the utils file and this is done, and insertion part will be much better, but however this is page overflows and is primary get index is leaf will be much better before writing this insertion logic. So since this is page overflows and get the primary index is basically inside this page class page object, and I will rewrite it on this file because it belongs to the page. So export function is page overflows, return if it will receive the node if the node that record keys length is bigger than this node that record keys that max length keys. Yes, so there we so we just can use these properties just to get the is overflows logic. So is overflow is kind of a pure that what it just is, it just returns the boolean value or that. But however, this max keys, the potential value is no, and I would say if node max keys length is no, or yeah, if it's no, I'm just gonna put the default value as 0. Next thing is primary index. I would do like exactly same as the is page overflows logic, and I mean like the function here, get primary index of page. This minimum degree dot -1. Now I just implement this kind of the function that represent the boolean value is overflows, or this get is leaf of page get leaf. No, I think is leaf is more better. Yes, so the the basic simple functions already migrate the basic simple functions, so it's pretty good. But next thing is the search logic. Search logic has to be indefinite, and it has to be separated into search, because search is could be search in the page or search in the tree. Search in the tree requires recursion, but I would make search in the page first and then implement search in the tree. So export functions search in page. The reason I name as a query key is, since I'm not even a front-end engineer, I know as a query key is that also means that that's the key that they're trying to find. So rather than like naming as the key trying to find, I would name it as a query key to make it simple and compact and meaningful. And this node, and I would, and this function has to be get a node, because this is not really the class based code, and this is the function. This has to be pure, and when you receive node and query key, it has to return um, if there's something query keys is um, is there's like key found it in its current page. Um, the um, first thing I have to do I have to do is inside the searching the pages for first is um, make condition um, that that um, make condition or early return if um, if cannot compare the the value between query key. And next thing um, I would do is write down find logic. Third, um, write return this boolean after the find logic. Yes, so I think this three step we're gonna represent the search in the page, and now I'm just gonna implement like that. Now, since record keys could have empty array, and I would return if this record keys the length is equal to the 0. If it's 0, I don't have to do it. So the search in the page return is no. But I think rather than boolean, I return the node or boolean is gonna be more better. No, I think node and the node values would better, because the sometimes I wanna manipulate the page, the node, when I found in the using the search in the page function. So if there's like if there's like record keys but it is empty array, return no, else have to else here I think it's better like copy this logic here. Const query exists, query key exists if this record keys, find the keys. And if the query key doesn't exist, return no. And if it exists, return the node here. So it's really pretty simple. Rather than putting as a record keys in the find, I think making as a and using JavaScript find logic could be easily detect this query exists. If it doesn't exist, return no. If it exists, return no. So that search page is kind of pure here. The next thing I would do is search in tree. Since this tree requires recursions, the first thing I will have to do is use early return that to prevent the bug or error. And next thing I would do is use search in page function to find query key in current page. Next thing and last thing is return the final make the getting next index logic for traverse into child. The next thing is return no or node. Since search in page, we basically return boolean. The reason why I say return boolean is because the search in tree sometimes it doesn't really use for the finding the node. Yeah, I think this using node return node or no would be much better because well we could manipulate this return node that exists, that core key exists in this tree. So or return that prevent bug. So early return prevent bug could be since this early return logic hack is in the search in page, I would put search in the page first. The page after search. Page after search, page after search, searched page, query the page after query. Yeah, I think this is much better. Search in the page, and if this page after query, if it's no, I would return no. If it's not no, I have to find this next index logic. Since I already make the next index logic here, however, this code is not 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 that great. So because this doesn't seems like searching for the next index, and this logic could lead some kind of problem because and the barber name and this logic doesn't represent this is finding next index. Since next finding next index could be widely used in even deletion or insertion, and I would also declare as the function to increase the reusability. As per function, get next child index for traverse. Get child idx for traverse. Yes, I think this there could be much more much better the function name, but I'm just gonna do it. So here's the thing of this next child index, getting next child index. The reason why I use the find index and I compare as a query key and I the reason and also the reason why I I find index that is smaller or same with the query key is because if you look at the Btree, it's not kind of really normal tree. If it's like binary tree, I can use pointer, but Btree is basically it's just the array with depths with array. Example, and this is um 1 4 3 6 8 7 2. So this is kind of really the item that you want to insert, the query key that you want to insert, and let's say your minimum degree is 2. So your max key is gonna be 3, right? So let's insert the 1 first. 1 and 3 and 4 and 6. Since 3 is already exceeding this max keys length, so I have to make these 3 as a primary key and post it to the parents. So this 3 is gonna be here, this 1 is gonna be here, and 4 6 is gonna be here. But you think that this 1 is actually left pointing this 3 pointing the 1 and this 3 right pointer is pointing to forward 6, but actually this is not. If I'm trying to use it as a different describe as of some kind of object or the data, the real data, it actually looks like this record kiss gonna be this 3, and this children actually is the page. Children is actually this. It looks like this. So children is gonna be array, and this index and the value is actually it's just a page of it because the children has the multiple pages. So it's just like record kiss has the 1 and children's is gonna be like is gonna be empty array. Since this record keys has the 4 and 6, we have to put it like 4 and 6 here. And of course, this is gonna be has to be array. So the question is, okay, now you're here, but when you're trying to insert 7, you have to insert in here. Since, however, there's no pointer, and you might think, well, we have to use pointer, but you don't have to do it. And since 7 is bigger than the 3, let's say 2. Let's say we want to insert 2. We have to just insert 2 on the left part. So left part is actually the 0 index in these 3's the children. So back again. So when you're trying to insert 2, we have to find this target or target pointer. Since there's no pointer, you just find the index, because the 3 is 2 is smaller than 3. You have to go left. The most left part is this page that has record keys, which is only 1. To find this kind of index, to find the index, you can just use sorting. You can just use get the index that is smaller than the current key. Example, the parent is 3. The 2 is smaller than the 3, and the index of the 3 is 0 here, because 3 there's only 0. And basically your 2 is smaller than 3, and it has to go to the index, which is 0 of these 3's children, your index of 3 children. For if it's like 7, you plus 1 of these 3's index, so that's gonna be 1. So what I have to do is, I think, find index so that current key is more or same than key. So next chart index is gonna be index gonna be left. So I would say I would make some kind of bar that represent this current keys go to right or left. If since if the next child index is 1, which is also means that this child index, there's no current key that's smaller or same than in this list of these record keys. If it's -1, we just have to send this rightmost of these record keys. So example, if I'm trying to insert 7, it has to go after the 0 plus 1, so that's gonna be the length of the array, which is 1. So we just have to get the record keys length, and this now we just have to use the child index as a value. And now we find the safe index that traverse. And so now if this node is live, we have to send the node here. If it's live, we don't have to we have to return for the IDs first. So right now, if page after query is null, and if it is live, we just have to if the page after query could be null, because I mean the search operation has to be done after it's reaching the children. So if it's null, and okay is live is equals to the node. So Yeah, if it doesn't find, it returns no, right? And we have to make sure that it is live. And if it's live, and if the page after query is no, that we didn't find it, we return no. If it didn't, we use get next chart in IDX for the traverse that to get the safe to get next IDX for the traverse. So I'm just gonna put this function under here. So next index gonna be this children's the children of the current page that has the after the search. Next, return these and now using recursion, we would traverse this same logic even the children part. Starting the page, sends back the current key, sends current key again, and next part is children and IDX. Yes, so this would be nice. And last, I think, sorry about it. Keeps talking about. I think, but if this is live, and if the page after query equals to the it equals to the no, but if it's not no, that means we found it. So after page query, returning page query will be more nice because page query is either node or no. So let's run it. Since there's no kind of insertion part, yeah, I think there's insertion parts. I'm just gonna hard code with the hard code with just using temporary variable, temporary node, Btree, yes, Btree node implementation. Next thing I would do is return pass down the record keys that can have the 3, 4, and 5. CRG temp node. Yeah, so I'm just making some kind of dummy array to test this search operation is correct. Now, if I try to pass down this our target query key, which is gonna be, let's say our target query key is 4. Query key is 4, so we're just gonna pass query key, and our notice this. So if I so the query key is 4, and this temp node has the record keys that has the 4. So the answer is gonna be the node, and let's try it. Yes, so since this is we return node rather than node, this is pretty fine. But if I say tranny, it return no. So that's pretty nice. And next thing I would do is using search in tree. Let's just let's just add more about children's part, because we need children to we need children values to test the search tree recursion. Btree implement with the record keys gonna be 1. This is gonna be 3. I'm just gonna make it as like this part, 46 functions. Children part is gonna be 46. Yeah, so in this part, I said just 3, right? So given this example, this parent is 3, and the left part is 1, and the right part is 46, and so this is kind of representative of for the test page. And let's now check the search in page again. So it returns as a no. Yes, that returns as a no. And let's say search in tree. Let's use the search and tree. Search in tree. Our query key is gonna be the 6, because 6 is most right part of the Btree, and it's kind of children of the page. And 1, 2, 3, of course, it will return as a node rather than no. Node record cases now. Oh, wait, this is, I think, this logic. There's something wrong with this logic. Search and page could be working. Node, it return node. Oh yeah, I didn't pass the node part. So if I pass it, it will return as a node. Yes. So that's pretty fine. We just now found the most right part of the children that belongs to the root of the tree. And now I would pass the 20 to test this value is no. Yes, so that's kind of really pretty fine the functions. So to recap, rather than rely on the page class, make the functions, because sometimes the using as a using class could be lead the bunch of the dirty code, and lot of lot of um lot of like big tech company, or a lot of library, they use the function rather than the class. Moreover, this is gonna be really great if I integrate with the TypeScript. So this is gonna be interface with read-only value. So searching the page, searching the tree, really it's pretty works fine. There's nothing worse than it, and it's gonna be it's a little bit pure, but I think there's more better approach than using as a recursion. And rather than using recursion, I would say while syntax is gonna be much better. Yeah, we can just do while. We have to search if this page query, let found it, it's gonna be false. If query, if this node is node, if this if leaf is node, we have to return the page query, or we can just break it, but I will just return it. Next thing is get next child for the inverse and next node. And I think this is gonna be really great because before I use the recursion. So basically recursion is kind of it could be great, but if the logic is gonna be longer, it's kind of hard to tell which one is gonna be return value. Even React, the dev teams, they use the while syntax to handle this kind of pointer issue. Now if I run it, this could be this is not working. So is this leaf return it? Wait, yeah, target node. I have to put the target node here, so it has to be return node. Yeah, so that's pretty fine. And that's this do while is much clean and is kind of really able to track which one caused the bug or which one caused the infinite loop. And now if I try to put the one here, query keys one, because one is most left part of these children. So if I run it, boom. So this search in tree and search page is working pretty fine. So this is it. Have a nice session next time. Bye bye.